Now we have two questions that are relatively easy. The first one is question 3.49. The question gave us a wavelength of 550 nanometers in vacuum and asks for the wavelength in water with refractive index of 1.33. We know that velocity in bulk medium is equal to speed of light over the refractive index of the medium. Also, the velocity is equal to lambda medium, let's say, or lambda prime, let's say, nu. And the speed of light is c equals lambda 0 nu. If I substitute these two equations into the equation 1, I will have lambda prime nu equals to lambda 0 nu over n. The nu, the frequency does not change. This is an important information. The frequency does not change in bulk matter or in medium, let's say. But wavelength does. Okay. So keeping this in mind, we can cancel the frequencies out on each side. Then I will have lambda prime, the wavelength in medium, will be equal to lambda 0 over n. And I was given a lambda 0 of 550 nanometer. You know that nanometer is 10 to minus 9 meter. But in this case, we don't need to write the wavelength in meter form, because our result will be nanometer as well. 550 nanometer over 1.33 will give me 413 nanometers. If you get confused about this equation, on which side should we divide to n to refractive index, or for lambda, which lambda is greater than the other, if you get confused about it, just remember that c is our maximum value, which will be equal to 10 to 3 times 10 to 8. So no speed, no velocity can exceed speed of light, especially in medium. Then also refractive index is usually higher than 1. Let's make it this way. Higher or equal to 1. The lowest refractive index is an air, which is almost equal to 1. So if we divide some number to another number which is greater than 1, we will find a smaller number. What do I mean? If I divide c over 1.33, my results will be smaller than, the velocity will be smaller than c. Then if you get confused, think about it. No velocity can be higher than the c value. Then I need to divide c value to refractive index. The second question is again about light in medium. It's a little bit similar to the first one. In this question, we need to find the distance that blue light travels in water with refractive index of 1.33 again in 2 seconds. So we have an n of 1.33 and t of 2 seconds. We know that from physics 109 and even from high school, x is equal to vt. We will apply the same thing, but this time for v, we need to write c over n, because our velocity in medium will be c over the speed of light over refractive index, which will be 10 to 8 meter per square over 1.33 will give me, actually we don't need to calculate this one. Let's directly write in this way. C over n times t will give me the c, the distance, So 3 times 10 to 8 meter per square over 1.33 times 2 seconds will give me 4.51 times 10 to 8 meters. Be careful about the units. Here I have meter per square. Refractive index is unitless and my time is of course seconds. So they cancel them. The seconds will cancel each other and I will be left with meters.